Welcome to Using PowerShell in a Cross-Platform World. Thanks everybody for coming. And just as a thank you, I'm going to leave that pun up on the slide. I won't say it out loud. You guys, you'll have to work a little harder if you want to boo me there. So some of you may have noticed I'm not James Pogran. James Pogran is the smart guy that originally came up with this talk, got it pitched, put all the smart bits together, and then he had a personal thing where he couldn't show up. And then through an act of organizational nepotism, basically, I'm here to give you this talk instead. He's a teammate of mine. All of those things on the slide up there about us are true, and I'll just trust that you've read them by now. We have some PowerShell release history to go over, or at least we did when I was making this slide, but thanks to the keynotes, they've covered most of this for me. So we can kind of breeze through most of this. The only thing that I really do want to touch on here is the experimental features. Is anybody familiar with experimental features in PowerShell yet? Great. Experimental features, look into them, get-experimental feature if you're in PowerShell Core. These are a really awesome way for the PowerShell team to release new functionality to us without actually having to fully support it yet, where they can kind of gather feedback. And the one that I want to talk about is the temp drive. I know this is early and we're kind of diving into it, but one of the experimental features is the temp drive. When you start to move your stuff over into Linux, sometimes you need to write a temp file, scratch file, something like that, and you could end up with not a lot of it, but a little bit of boilerplate code in a lot of your scripts that you have to kind of repeat and maybe even template, whatever. Use the experimental feature, use the temp drive. If you're coming from Pester, this is going to be really familiar. Just let the language figure out where to put those temp files. The speed improvements for PowerShell Core are really big. I help run the Portland PowerShell user group, and we had Jaap Brasser on a little while ago to demo some of those speed improvements, because PowerShell 6 has really been focusing on speed improvements, and some of this stuff is eye-popping. PowerShell 5.1, they did a background job sort of demo task that took 1:30. PowerShell 6x, background jobs, cut it in half. And then thread jobs are standard in PowerShell 6, and that took it down to 300 milliseconds. We're less than 1/3 of a second on the same task just by going to PowerShell 6, and we're not even cross-platform yet. So that stuff's really exciting. And then PowerShell 7, notice the dropped core. I don't know anything more about that than you do at this point, thanks to the keynotes. Thanks to them for putting that out there. I'm pretty excited about it. I hope you are too. It's based on PowerShell and .NET Core, thus the core in the name. We won't focus a whole lot about that unless you have questions about it. You can talk to me offline, but it's a smaller version of .NET Core, so we can go cross-platform and enjoy all this goodness on Linux and Mac. But as some of you know, there are things that are missing because it's on .NET Core, so some of those APIs are gone. Which means that some of those modules can't be used. And I know that I get a lot of feedback when I talk to people about PowerShell Core that they say, well, I'd love to use it, but Active Directory isn't there for me. And I have to use Active Directory in my daily workflows. We'll see in just a little bit that that's not entirely hopeless, but as of now, it is gone. Some of you may have noticed that in the PowerShell 7 announcement, the idea is to bring a lot of those back. So kind of hold out hope, and again, there's a technique that we can use to get some of those back anyway. This is also different. Some of you may have noticed already, PowerShell Core, especially when you start to get into cross-platform, it's not actually called PowerShell.exe anymore, it's PWSH.exe. There's a link in the slide deck, in the notes, the speaker notes, to the discussion about how and why this happened. But the short version is that PowerShell Core has enough breaking changes with PowerShell 5 that especially if you aren't cross-platform yet, if you're using PowerShell Core on Windows, you don't want to invoke PowerShell and have ambiguity about which version of PowerShell you're going to get. You don't want to accidentally get PowerShell 5. And if you construct your path variable in just the right way, and if they didn't do this name change, you could run into situations like that where your script would accidentally run on PowerShell Core and things would break. And everybody would be confused and angry, so PWSH.exe. This was the slide I was originally going to talk about PowerShell 7. This is all stuff that you know by now. If you have more questions, does anybody have questions about that? Great, so we can just kind of move on. Why choose PowerShell? This is going to seem a little bit obvious to people in a PowerShell conference, but the real question here is why choose PowerShell for your cross-platform scripting needs, right? Because there are other cross-platform scripting languages out there. Clearly, there's Ruby, there's Python, there's Node. And they have their advantages, but I think PowerShell has a lot of particular advantages that a lot of us here are going to be interested in. So one of the big ones to me is that PowerShell is designed as a shell and a scripting language. And a lot of these other languages, they might have a command line interpreter, but they are not designed as a shell. Like you would never use the Ruby IRB as your shell. It's just not a good experience. And it's the same with Python interpreters and that kind of thing. That's not a shell. PowerShell is a shell and a scripting language. There's almost complete parity between the two. So as operations people, like a lot of us are, we're not software developers or operations people that fiddle with stuff until it works. Well, you can take all that fiddling and stick it in a script and expect that it's going to work. And that's really, really powerful, especially for other people coming from other languages that aren't used to that experience. When they start to see how powerful that can be, you know, they really start to like it. Remoting, a lot of these other languages aren't going to do remoting the way PowerShell does. We just had a remoting talk, I think it was yesterday, but having the remoting capability in your shell, whether you're on Windows or Linux, I mean, that's really big, having a consistent remoting experience and being able to take some of those remoting techniques and put them in your scripts. Remoting is really, really big. I really like to point this one out because a lot of us here in this room, of course, have invested a lot of time into learning PowerShell, or you're on that journey, right? And as knowledge workers, that time that we spend learning a new technology, that's one of the most precious resources that we have. You're not getting that time back. You could have learned other things. So learning these new skills is incredibly important. And when you start to take these PowerShell skills and apply them to entirely new platforms, I mean, that is a really, really big win. You can start to take existing skills and apply them to just this whole nother field of endeavor. Now, these other languages do have disadvantages. I'm going to talk about them, but I just want to point out that I'm not bashing these other languages. I don't need like mean tweets afterward. Bill doesn't like Ruby. That kind of thing. But, you know, we'll just hit on a couple of them. They can be difficult to use and install. Some of them have installers, MSI installers. They might even have a package, but getting the rest of the environment set up can be pretty bulky, and it's not a great experience. Then once you're up and running, sometimes the ecosystem is hostile. There's really commonly used packages that the rest of the ecosystem is using, but then you try to use them on Windows on, you know, cross-platform code, and it's broken because they didn't really design it with Windows in mind. They didn't test it on Windows, you know, all that kind of stuff. So now that we've decided to use PowerShell, I'll just assume you've decided to use PowerShell cross-platform. How do you go ahead and get started doing that? Well, PowerShell Core is just an application that you install on the system. It's not like it used to be where you had to do a whole new server version, right? So installing PowerShell on all of the platforms is all about the package managers, which means that it's super easy. A lot of you already know that on macOS, that's all you got to do, and you're up and running. On Linux, I'm just going to admit to you that I'm cheating a little bit. There's a little bit of setup code you need to do for each of these repositories before you can run that command. And which package manager you're using is going to, you know, change a little bit depending on your distro. But as soon as you do that little bit of setup, you can just do install. And this is another one, by the way. In the speaker notes is a link to the specific directions to do this setup, so you don't have to kind of take my word for it. The link to the documentation is right there when you go to the repository. And on Windows, it's that easy as well. You just do choco install. I understand that a lot of you are not using Chocolatey, or you're in an environment where Chocolatey is you know, not in use yet. You know, you can't get it installed. So you could also just do that. This is, full disclosure, a script that I stole from a Steve Lee tweet. And the only point here is that installing PowerShell Core is so easy that it fits in a tweet. It's just something that I thought was interesting. So PowerShell Core cross-platform is good at some things. It's not quite as good at other things. So one of the things that it is really good at is interacting with web services. Does anybody here go to Kevin Marquette's talk about the web commandlets? Yeah, great. I had originally a slide where I was going to talk about the web commandlets, but I'm just going to tell you ahead of time, you're not going to get it any better than you're going to get from Mark Krause. He wrote some of that stuff. So I do encourage you to learn more about them if you're interested in PowerShell Core. Please look at the YouTube videos later on. I won't touch on them too much. But if you're interacting with web services, even if you're not cross-platform yet, the web commandlets are so much better in PowerShell Core that it's worth the move up to Core just for the web commandlets. Especially if you're dealing with open source and cross-platform products, even from Windows, a lot of them behave in open sourcey ways that aren't going to make the older web service commandlets happy. So if you're running into problems, try Core, look at the new switch parameters that are available. You're really going to like it. It's really good at data conversion. So if you're hitting REST endpoints with JSON and you're doing it from Linux, maybe your Linux admins are doing it, ask them how they do it, right? There's a good chance they're using curl and then they're piping all this stuff over to like maybe JQ or something like that. PowerShell is so much better at this. You can hit the REST endpoints. You're going to get PowerShell objects back. You can write the PowerShell objects out to JSON or XML or whatever. PowerShell is really helping you abstract away even the fact that you're dealing with some of these languages. You can just deal with the objects and worry about the output and input formats later. It's going to make it a lot easier. Cross-platform PowerShell is great for build scripts. So if you have an open source project that you're working on, maybe you're maintaining it internally, and you want to start interacting with that project on Windows, maybe it already has a build.sh script. These build.sh scripts in a lot of cases are very difficult to understand. They're configured with environment variables, and they're not going to work very well on Windows. It's hard to execute build.sh on Windows, right? Give it a PowerShell build script, and everybody's going to be able to use it cross-platform. You're going to be able to wrap things in functions. You're going to get parameter completion. You're going to get all of that. You might get a little bit of resistance from your Linux guys, but just show them the light a little bit. I know it's harder than that, but everybody will like life better. Pester is cross-platform. Pester is so good that it's worth calling out on its own, especially when you consider the fact that on Linux you can start to use Pester for things like system validation. So you can take various aspects of the system state, run it through a Pester test, and get validation that your system is in the state that you expect it to be in. And then you can do things like take all of those tests. I expect these files here. I expect these Nginx settings to be this way, whatever. And when your tests are done, you can output that test to things like NUnit XML files, suck them up into other places. I mean, there's just a whole world of possibilities there. There are things that it's not the best at just yet. One of them is reaching its fingers into the operating system. And the thing to note here is that PowerShell was designed to work with an operating system that is API-based. And it's designed to work with one operating system's API, not necessarily a whole bunch of them. So there are things like the get service commandlets aren't there. If you're using transactions in PowerShell, that's not there. You're going to have to do kind of a lot of manual file system kind of stuff if you want to do those kinds of things. WinForms isn't there, so interfaces are kind of out. This is just a minor thing. If you're doing things like you're piping ls to grep and you expect that colorized output, maybe it's just the shells that I'm using or the sessions that I'm using. I don't get that colorized output. It's kind of sad. So now what is it like to use this thing on a daily basis? Well, for the most part, PowerShell is going to try to behave the same as it does on Windows. But it is trying to be a good citizen on Linux. So things are stored in slightly different places. This slide is going to show you, some of the places where it's keeping things. But I think one of the main things to take from this slide is that you don't have to memorize all of the places where those things are. The environment PS module path variable is still there. The profiles variable is still there. So you can still do, if you wanted to, something like vim profiles.current-user all hosts, and you'll get it. Even if it differs from distro to distro, you don't have to memorize all that stuff. The language is helping you. This slide here is kind of showing you that getChildItem is operating the same as it does on Windows. It's going to work just fine on Linux. But in this example, I've taken a file and I've marked it as executable. And getChildItem isn't going to show that to you. getChildItem is just going to show you all the things that it knows how to show you. And there's properties that aren't being displayed there. But it doesn't really have a concept of executable because the place where it comes from doesn't have that concept. So you're going to need to use ls to get that executable bit. And the only point here is that PowerShell is operating the same, but you are on a different platform. So you're not totally off the hook for learning something about Linux. You do still need to learn about something about the place where you're running. And also, on the subject of running it as your daily driver for your daily use, how do you make sure that PowerShell is the shell that you use on a daily basis? And to do that, what I have here is I have a terminal that's ready to SSH into an Ubuntu machine on which I've already installed PowerShell. And when I SSH into it, you'll see that I'm in a bash shell. That's not really what I want on a daily basis. So what I'm going to do is I'm going to confirm that PWSH is available as a shell, because it is. You can make that your daily driver shell if you want to. But what you can see there is that I've got 2 copies of PWSH. And the question is, which one of those do I want to use? Well, if we look at the properties of the user bin PWSH, what we'll see is that it's not actually there. It's just a symlink to the opt copy that Microsoft put there. And so what we're going to do is we're going to change our default shell. I'm going to change my default shell to the user bin copy, the one that's symlinked. And then as the machine's life cycle goes on and we do system updates maybe, updates to the PowerShell version, the symlink will get updated to the new version. And everybody that has their default shells pointed at the symlink, their shells are still going to be OK. They're going to get the new version by default. So that's kind of what that's there for. Linux likes to do a lot of this kind of symlinking stuff. Windows admins, we're not really used to it. getChildItem, by the way, has actually been improved to handle symlinking properly. Initial versions we used to try to follow symlinks like all the way down. It won't do that anymore. You're OK. This command is just changing the shell for my user. I'm logged in as root. So it's just my user. So if you have Unix admins on the box, you're not going to ruin their day. You can just do it for yourself. And what you'll see is now that I'm logged back in, PowerShell is the place where I land. And when I exit out, you'll see that I don't exit out to bash. I exit out back to my host box. So this is a way that you can make sure that on a daily basis when you land in your Linux boxes that PowerShell is where you're at. So here's where I get to talk about various places that James and I and other people have kind of stubbed our toes about the move up to Linux. These are just kind of gotchas that we've run into. One of them is environment variables. Environment variables on Linux by default are all uppercase. And if you iterate over the environment drive in PowerShell on Linux, you'll see that they're all uppercase except for that one. That's a special case. That's our special case right there. And the reason is that a lot of authors, when they were moving their stuff, environment variables are case sensitive. They're not on Windows. They are on Linux. They're case sensitive. And so people would move their scripts, and their scripts would start to fail. They would get nulls from that one because they missed. And so the team decided that there was enough of this going on that they said, OK, fine, we give up, and we'll do the camel case on Linux. So that's the only one that you'll find. And there's a link to in the speaker notes to the whole discussion about how that happened. But it was just to avoid all these pedantic little edits. You just can go ahead and use it. Module names are another special case. If you're in Linux and you do import module just name, case insensitive. But if you give the full path to a module, that's case sensitive. And again, there's a link to a bunch of discussion. This was a little bit controversial because modules are backed intrinsically by file directories. But the team made the decision that this is just a little too fiddly to have case sensitivity if you just want to use the name. Nobody wants to have to remember that kind of case sensitivity, especially since so many modules on the Forge are like this weird camel case everywhere because we're used to that case insensitivity. So if you're doing module development, though, and your working directory is somewhere else on the disk, it's not on your module path, so you provided the path to your module development area, that's going to be case sensitive.
What happens if you have two directories
They're different modules. Because on Linux, they're totally different directories. So in that case, if you're only using the module name, right, then it's based on the environment PS module path, and it's going to be whichever comes up first, right? Platform variables. Platform variables are not case sensitive because they're regular variables. But the thing is that they're so important, I want to touch on them here because you can do things like this. And this goes to strategies for the maintainability of your code, right? And I want to give a shout out real quick to Tyler Leonard, who gave me the idea for this particular switch construct. It had not occurred to me to use a switch in quite this way. But the idea here is if you were authoring a module, right, and a lot of us are authoring modules with an idea where you have public commandlet function definitions, and then you have all the private plumbing stuff in a private folder, right? Your public implementation should read very much like a series of English sentences, to the degree possible. When I talk about these things, it's all ideal world. I know nothing is quite perfect. But things should read like an English sentence top to down, and it should be really easy to figure out what's going on. But when you start to get into cross-platform, sometimes doing the same task will have different implementations on the two platforms. If you need to get a particular piece of data, you won't do it in the same way. And so your public implementation should just say, get piece of awesome data, right? And then in the private backing script, it should have this construct. And what you'll have is if you're on Windows, it should say, get piece of awesome data from Windows. And then Linux, get piece of awesome data from Linux. This becomes especially important as the complexity and the differences between the two platforms become more and more divergent. Because if you try to munge all this together into a single script and it's all interleaved, this is a maintainability nightmare in the making. Because if you have one difference in implementation, like Ubuntu comes out with a new version and you've got to do something different, now you've got to dig through this whole big private thing where everything is mixed together, and you might contaminate your Windows results in a variable. You just don't want to be in that world. So this construct right here is really going to help you make sure that you have the separation of concerns in your private implementations, that all of your logic is nice and separate and easy to maintain. But the platform variables are a little bit coarse. You're going to know that you're on Linux, but you're not necessarily going to know that you're on Ubuntu or something like that. And this one, full disclosure, I stole from a Mark Krause script that he wrote quite some time ago. Some of you may see already that it's not necessarily up to date. There's a link to the script in the notes. But this is just kind of an idea of a pattern that you can use to get more detailed information from the operating system. And I especially want to point out the convert from string commandlet right there. That is new to PowerShell Core. You get it on Windows as well. And the win here is that some of us are in a cross-platform world, not in the sense that we're logging into Linux, but in the sense that some of these Linuxy products are starting to do things on our Windows boxes. So you're starting to get these Linuxy types of files on our Windows machines. And that's what this commandlet is intended to help you out with, among other things, is to parse those, value equal or key equals value type, very generic files. So if you need to get information about the open source product that's running on your Windows machine, you can start to pipe that content into that thing right there, and you can get that kind of information really easily. File encoding becomes a problem, especially if you're taking scripts that have a long life. If you have a script that maybe started its life in the PowerShell 3 days, it was originally authored on ISE, that kind of thing. Excuse me, I'm just going to take a quick pause here. Does anybody have any questions, by the way? I feel like I'm moving kind of fast. Great. So if your scripts have that kind of long lifetime, you may not even notice yet that they're UTF-16 encoded. And I call that out specifically because UTF-16 encoding is going to cause problems on Linux. Windows, that was the default encoding for a while because of international characters and whatever. Linux is UTF-8 only, basically. If you're in that world, just use UTF-8. I put ASCII up there. We can talk about offline if you want to get geeky enough to talk about the difference, but just use UTF-8. So how do you know if you're going to have an issue with that? There's lots of commands that you can use out there. They're mostly implementations on Stack Overflow and that kind of thing. Don't go reinventing the wheel. If you look at the slide deck on your own computer, that's a clickable link to a Lee Holmes implementation of one of these commandlets that will help you out. Just fair warning, if you have a fairly generic file, it's an ASCII file, and you use the Lee Holmes script, sometimes it'll tell you that it's UTF-7. That's okay. UTF-7 is fine. It's probably just ASCII or UTF-8. Don't worry about it. But having an issue looks like this. The first screenshot up there is just to let you know that you're not necessarily going to see visually in your editor that you're about to have a problem. But that second screenshot, when you look down there, that's the lower right-hand side of Visual Studio Code. And you'll see up there that it does say UTF-16. And then that's just a hex dump. We won't talk about it. But the last screenshot there is one of the examples of the kinds of problems that you can run into. When you start to do cross-platform workflows, a lot of times you're talking about Git workflows. And Git has issues with UTF-16. If you change 2 lines in a file and you try to do a Git diff, it's going to say, nope, that's binary. Well, I can see clearly that it's not binary Git, thanks. Well, it's because it's UTF-16, and it doesn't really know what's going on with that. So to fix it, there's a couple good ways to fix it. One is to actually, you can click on that UTF-16 right there. And what you're going to get is that menu right there. When you get that menu, click on Save as a different encoding. The menu that pops down is going to ask you which encoding that you want. ASCII is not even an option. Just click UTF-8, and it will convert it for you. That second one, of course, doing it in the GUI is not always real feasible. So if you have lots of files, you know you're going to have an issue. Just start to treat them on the command line that way. Just fair warning, the assignment to a variable and the lack of piping from one to the other is deliberate. I don't know how many people have run into this before, but you can't pipe from a get to a set on the same file. Get content is going to start piping stuff through before it's actually done, so you've locked your own file. So you're going to have to assign to a variable first and then do it. You can prevent it with a number of different strategies. We won't spend too much time on them, but there's things that you can do, especially if you know you're going to be doing a lot of out file and set content, that kind of thing. You can set defaults if you want to. Using modern editors is good if you're starting a new file. If you do file new in modern versions of ISE and VS Code, you're going to get UTF-8. It won't help you so much if you have those long-lived scripts that are already UTF-16. Line endings. Some of us already know that line endings are different between Linux and Windows. And these will trip you up in kind of unexpected ways. And the reason they're unexpected is because Windows already knows how to accept Linux line endings in most places now. I think Notepad's been modified to take them. VS Code will accept them. I think ISE, I'm not sure, will accept them. But the point here is that Windows and Microsoft are the ones kind of moving in that direction. Linux is not. Linux is making no effort to accept CRLF line endings. And if you accidentally put CRLF line endings in things, things will start to break. So what you can do about that is you can use VS Code to convert. If you go back to the screenshot before right there, to the right of UTF-16, it says CRLF. You can do the same thing. You click on it, and it'll offer to convert it for you. And you can also convert it in on the command line. We won't go too much on that, but you know, it's really not worth fighting about. If you're going to be doing cross-platform scripting, you're going to be doing cross-platform projects, just go ahead and use Linux line endings. You'll do the conversion once. You'll never notice the difference. Paths. PowerShell is accepting the Linux paths everywhere now. Almost anything you can do in PowerShell, you can use that / because PowerShell is doing path normalization everywhere. It's taking whatever paths that you pass in, this is a tongue twister, and it's going to tokenize it, and it's going to build that path for you. If you're doing a lot of cross-platform, you might even save yourself a little headache and just start using the / on your command line, so you don't have to do that mental switching. But there's no reason to get sticky about your backslashes or to have to do some sort of string conversion. Am I on Windows? This path separator, just don't bother. Join path is also your friend here because join path is going to let you programmatically build paths that are native to the platform that you're on. It's also worth noting here that that additional paths parameter, that's new to PowerShell 6. The old join paths didn't used to have that, so you had to do, if you were building deep paths, you had to do like some pre-processing or whatever you were going to do. But it got that with PowerShell Core. Aliases are not your friends. So some of us have been saying for quite a while, please don't use aliases in your scripts. And it's just kind of getting worse, the situation for aliases. They're mostly going away. This is a list of aliases that are already gone. Some of those you already know are gone. ls and curl, those were pretty controversial, and everybody was pretty happy to see those gone. They were causing a lot of problems. Sort and select took some people by surprise. Those felt safe because sort and select didn't correspond to binaries that were on either system, but just to let you know, they are gone. So if you're going to take your scripts, and even if you're not going cross-platform, if you're just going up to PowerShell 6, you're going to run into syntax errors with that because that's not actually a thing anymore. So please don't use aliases. This is a list of aliases that, as of the version I was running, are still there. And these are kind of dangerous. Like kill up there is a binary on the system, but it's been aliased to a commandlet. What is it? Echo is aliased. So especially if you are, if you start to evangelize this to Linux people, you say, hey, PowerShell's great, you should try it. And they try it, and they want to use kill, and they have a bad day. Like, they're not going to like you too much. But, you know, at least be prepared for it. I will say that there's a link in the speaker notes as well to the discussion about how to get rid of aliases from the language completely. Please don't despair, though. You'll be able to get them back in the command line. I don't think anybody's going to pull the trigger on that without a way to get them back in your command line. But from the scripted environment, I don't count on any of them being there. It's worth noting that some commandlets have changed their implementation between 5 and 6. And this will start to hit you pretty bad if you are doing cross-platform stuff, but some of you might notice even if you're not. So this is an example where the encoding parameter, like the encoding parameter still exists, but you might notice that on the lower list of available encodings that byte is gone. You can no longer do encoding byte to get the raw bytes of a file, because if you think about it, byte is not an encoding. It's just, you know, an output stream. So they changed the way the commandlet works, and now you have a flag on there as byte stream. So now if you want to accomplish the task of getting the raw bytes of a file, you know, get content is still there. It's not like it's a different commandlet, but the way that you call it has changed. And so this is something that's changed between the two versions, but you could get a lot of different differences like these when you go cross-platform. You know, when the platform has changed, so the way that you need to call a commandlet has changed as well. And so splatting to the rescue. This is where you're using the platform variables to decide the way that you should call the commandlet, even though the commandlet itself hasn't changed. If you're not using splatting yet, by the way, please do, highly recommend. By the way, that's a new platform variable. We haven't seen that yet in the slideshow, is core CLR. This is a valid platform variable for PowerShell Core on Windows as well, and it's your clue that you're running in PowerShell Core and not 5.1. So even if you're running on PowerShell Core on Windows, that is core CLR is true because you're in the core CLR. So you can tell the difference there. Who's familiar with shebangs? Is anybody? Yeah, this is kind of a new term to me. And I kind of giggled. I still kind of giggle, shebang. I don't know. But this is a way to natively tell Linux-type operating systems which interpreter that you want to use to execute a file. Because a lot of times on Linux, a file is executable, but it doesn't have an extension. That's not how Linux tells how to do things. There's no extension. So they use the shebang up there, and what happens is when the file is marked as executable, that is up there to tell the system, okay, when I execute this file, who's going to execute it for me? And a lot of times when you see that, it's going to be bash, it's going to be bin bash or whatever. But you can do the same thing with PWSH. And so you have a file on the system with a bunch of PowerShell code in it. That's just a comment. It's not going to break your code. But you stick it at the top, and then when you mark your script executable, then even if you're in bash, you can just invoke the name of the script, and it's going to run. PWSH was specifically modified to enable this behavior. If you do PowerShell.exe, what is it, -- help or / or whatever you do, and then you do the same thing to PWSH, you'll see that the command line parameter order has changed specifically to enable that. And it's super useful for Git hooks. Super useful for Git hooks. This is how you can ensure that your PowerShell script is your Git hook. And Git hooks are this great way so that if you do something like you want to have a Git workflow, when somebody commits, you can have a Git hook that ensures that all of your linter rules are okay and that all of your pester tests pass. And if they don't, nope, you're not doing a commit because the Git hook commit script has said so. But you can only get that to run even on Windows if you have the shebang right. And by the way, to get back to line endings, the only way to get that shebang right is to have a Linux line ending at the end of it. If you have a Windows line ending at the end of the shebang, even if you're on Windows, it's broken. It's not going to work. And if you don't know that ahead of time, you might be sad for a little while until Stack Overflow finally tells you what's going on. So I hope I didn't go through too fast, but that is most of my presentation. I hope you got some value out of it, and if you have any questions, I'm going to tell you, I don't know. So, so the question is, what does the pinvoke story look like on PowerShell Core? Has anybody used pinvoke before? Yeah? So the answer, by the way, in addition to the question was, the pinvoke story on Linux looks great. You can do the same thing. You can invoke the same C libraries, is that? Yeah, well, you can invoke. Right, so if you have a C library on Linux, you can import the thing in pinvoke and you're still a happy person. Oh, so what sort of stuff am I using PowerShell Core for? So I started to look into using a Go project because one of our administrators needed to modify the way that VMware built firmware for our Windows machines that we were deploying over there. And the utility that he was using was a compiled utility written in Go. And we helped him with it, but the build script for that project was extremely frustrating. The build script was, it's not even that it was super long, it's that it was only configured by environment variables. You had to read the whole thing to figure out what the variables were, what they were doing, what are the available values, I don't know. So I wrote a build.psh for it, wrapped everything in parameters, had the validate script with all the available values, everything was nice, and I was certainly a lot happier to use it. Yeah, so the question is, when you're interacting with the cross-platform, with the different platforms, are your private implementations packaging everything up into objects?
The data to normalize your data, are they a script per platform?
Right. So I think the strategy that I would go with there would be a different script kind of per platform. But the thing is that when you have like get awesome piece of data from Windows and get awesome piece of data from Linux, whatever you assign to this a variable between the two should be something that's consistent between the two of them. So whatever munging that you got to do to the data before it gets back out to the variable, that's where you want the consistency to be. Because you want all of the differences in the platforms to be hidden down here, and the rest of your script should have nice consistent expectations about the thing that it's going to get back. I think, so the question is, is there anybody out there using the platform variables to separate out the logic kind of into separate files and treat them differently that way? Yeah, so I think that gets back to the public and private functions a little bit, where a lot of people, when they're authoring their modules, like one tactic that a lot of the community likes to use is to use separate files for each function. And so your functions are getting separated out into the different files. And then you can choose to compile those all into a big PSM1 if you want to, or you can dot source them in their separate state if you want to. But that kind of, in my head, that's kind of analogous to where your implementations are in separate files, and so you don't have to like, clutter a single file with these differences in implementation. Does that answer your question? That's a good question, and that is a question that comes up. And there is a module. I think it doesn't have any commits for quite a while, but there's. Oh yeah, sorry. Is there one consistent way to deal with the clipboard across all of the platforms? So there is a good module out there, and I think Steve Lee publicly recommended it to somebody, and it doesn't get a lot more from the horse's mouth, really. So I feel comfortable recommending it. I wish I knew the name off the top of my head. Is that what it is? Yeah, so there's a whole module out there. Set clipboard text, I think, is one suggestion for what the name could be. Right. But the implementation of how you interact with the clipboard, and I think you know this already, but it is so different between the different platforms that this module is specifically built to interact with the different binaries on the different platforms that you need to interact with in order to interact with the clipboard. So that does help obfuscate that away from you. Yeah, great question. Well, thanks everybody for coming. Did I come in under time somehow? Okay. All right. Thanks.